Okay, now I will talk about section 10.2, which is rotational kinematics. Let us remember at first that linear kinematics, the equations of motions v2 is equal to v1 plus at, x is equal to x naught plus v naught in t plus half at squared, and v2 squared. You remember these equations in the first part of this section, this course. In rotational motion, we have the same as these equations. You need to remember that the time is the time, the acceleration, the linear acceleration a is the angular acceleration alpha in angular motion, yes. Also, the linear velocity v1 and v2 are the same, omega 1, omega 2 in angular motion. Also, x is the linear position, but we have theta as an angular position, x naught, theta naught, and so on. So we have x versus theta, v versus omega, a versus alpha. We have the same equations in angular motion. Just we need to change the symbols, but they have the same physics to apply. Let us look at this example now. This is a simple example. We have a body. Its initial velocity is 5 meters per second. The final velocity is unknown. If the acceleration is 3 meters per second, and we have a period of time is 10 seconds. We need to find the final velocity v2 and the displacement x, the change in position x2 minus x1, which is delta x. We have a circular motion. On the other hand, we have omega 1 is known. We have here v1 is known. Omega 1 is 2, not 5. 2 radians per second. Omega 2 is unknown. We have the time period is 5 seconds. We have acceleration is half radians per second squared. And the change in angular position is unknown, delta theta. We need to find the final angular velocity and the change in angular position. It is the same question. One in linear motion, one in the second is in the angular motion. Okay, now look, to find v2 I will use the first equation. v2 is equal to v1 plus at. v1 is known, 5. The acceleration is 3. The time is 10. Then the second velocity v2 is equal to 35 meters per second. Okay, on the other hand, omega 2 is equal to omega 1 plus alpha multiplied by t. It is the same equation but in angular motion. Omega 1 is 2. The acceleration alpha is equal to half, as we told you before. Okay, as given. The time is 5 seconds. Now omega 2 is equal to 4.5 radians per second. Just a number, just equation. We need to put the numerical values and then find the final result. Okay, now we need to find the change in position, x2 minus x1. We know that the equation, this one, the second one, x is equal to x naught. This is x final. And this is x initial. So x final is equal to x initial plus v multiplied by t plus half at squared. We need to find the change in position. So we need to move the initial value to the left side. It will be x minus x naught, which is the change in position. It is x final minus x initial, which is the change in position, which is equal to the rest terms, which is v naught, the initial velocity multiplied by the time period, plus half the acceleration multiplied by the period of time squared. we need just to put the numerical values. V initial is 5 as given. V naught or V1, just V initial, okay? The time is 10, half is half, the acceleration is 3 as given, and the time squared is 100. Then the change in position is 200 meters. These 200 meters, okay? Now the angular motion. We have theta is equal to theta naught. It is the second equation. Theta is equal to theta naught plus omega naught, the initial angular velocity multiplied by the time t period, plus the half multiplied by the angular acceleration multiplied by time squared. This is the same equation again. I move theta naught, the initial position, to the other side. It will be in negative. In this case, it will be delta theta, change in position, angular position, is equal to the initial angular velocity multiplied by t. It is the rest time terms. Now, just I need to put the numerical values. Omega naught is 2 radians per second. The time is 5 seconds. Plus half is half. Alpha, which is the acceleration, is equal to half. The time squared is 25 because the time is 5. 5 squared is 25. Now, the final change in angular position is 16.25 radians. This is change in angular position. Okay, it is just simple. You know how to use these equations. It is the same way we need to use them, but we need to use radians and angular velocities and angular acceleration. Another thing you need to be notice that if we have a circle, if the velocity is omega and the circumference for it is 2 by r, which is equal to omega multiplied by the time period. Omega, it will take capital T. This T is called period. It is the time that the body required to go around 2 pi radians. Okay, that's it. Thank you.